Let's look at two specifically, two reactions of amines. These are both going to be acid-base reactions where the amine is acting as the base. The first reaction that we're going to look at is when an amine reacts with water. And we're going to draw this twice. So we're going to look at two different examples. Remember, an amine is a nitrogen that's got 3 bonds. There's a lone pair of electrons on the nitrogen. And then on those 3 bonds, maybe the nitrogen is bonded to a hydrogen, maybe it's bonded to a carbon chain or just a little carbon like this. So this would be a primary amine because it has only 1 carbon chain attached. And these primary amines will react with water, which I'm going to draw in a different color so you can watch the water molecule in this reaction. And the product of this reaction is the amine, which does not lose anything. So all of the stuff that was on the amine stays there, plus the nitrogen takes one of the hydrogens from the water molecule. And the water molecule is left without one of its hydrogens. And this transfer of the hydrogen from the water to the amine, this causes the amine nitrogen to get a positive charge, which I'm circling. Circling the charges is pretty standard in organic chemistry, just makes it harder for us to not see the charge. So moving the hydrogen from the water molecule over to the nitrogen means that the nitrogen gets a positive charge and it leaves the oxygen, or what's left of the water molecule, it leaves that with a negative charge. Here's another example of this reaction. I'm going to draw this one using line notation. This is a tertiary amine because here we have 3 carbon chains attached to the nitrogen and no hydrogens. We're reacting with water again. And the products of this reaction will be the amine, which has not lost anything at all, plus one of the hydrogens from water has been added to the amine. That leaves water as just OH minus, which is hydroxide, and a positive charge over with the nitrogen on the amine. The other reaction that amines can do is react with a strong acid. So we're going to write strong acid, and examples of strong acids that you'll see on sapling will be HCl, hydrochloric acid, HI, hydroiodic acid, and maybe HBr. I can't remember if it's there or not. This reaction is very similar, so let's draw a couple of examples of this reaction. This time, for our first example, let's use a secondary amine. Here's a nitrogen that has 2 carbon chains, little tiny carbon chains attached. And here we are going to react with, let's do our first one with HCl. Just like with water, the amine does not lose anything. So every part of the amine stays there. Plus, the hydrogen moves from HCl over to the amine. And that leaves HCl with just the chloride. That's it. Now again, when the hydrogen moves, a positive charge moves with the hydrogen. So the nitrogen gets a positive charge and the chlorine is left with a negative charge. And let's do one with a line structure. Like this. So this time, let's react with HI. See what we get. So we do not change anything with the original amine. See how I've condensed the nitrogen and the hydrogen? I'm not showing an actual bond, but I've just smushed them together. We're going to add the hydrogen from HI to the nitrogen, and that's going to leave us with just iodine. The hydrogen takes a positive charge with it and leaves iodine with a negative charge. And that's it. That's all there is to these reactions.